All right, welcome back, everyone. Today we're going to be finishing up our app here and making a front end for our block, paper, scissors project. So you'll want to go under Packages, Next.js, App, and Page.tsx. And just like the default contract, we have a little default page here, which looks like this. And let's change this to make it suitable for our rock, paper, scissors game. So let's delete everything except for the first div because the first div centers everything nicely. And our goal here is just to make the debug contract tab look, well, to make our home page look like the debug contract tab, but nicer so that there isn't a bunch of weird inputs everywhere. What we're going to do is we're going to have buttons for rock, paper, or scissors. We're going to have a button that plays the game and then a reset button. So basically all the functions we already have in our Solidity contract. So let's start by going to Daisy UI, which is a beautiful component library, and we're going to grab a card. Let's get a card without a picture so that we don't have to delete it. This looks good. We'll copy that and place this here. And just make sure it loaded in properly. Great. So we'll have two cards, one for selecting the object and then another one for the game logic. So we'll just call this the input card. And we will ask the player to choose their weapon. And then we're going to have three buttons for each item. So the first one's going to be rock. And when the player clicks rock, we want to set player one choice if it's player 1 or 2. So we already handled this logic here. So all we're going to be doing is writing to this input function the player's choice. And it's going to be a number. So we need to keep track of state. We can get rid of this address. We'll get into addresses later when we complexify this game. So let's use state. So we'll have player choice. This is what we're going to be submitting into our Solidity function. And we're going to have set player choice, where we're actually going to be setting this variable equal to something. So let's use state. It should auto import from React. And by default, it's going to be the number 0. Cool. And another thing we want to do is bring in our function from the contract. We want to be able to call this function. So how do we do that? Well, Scaffold-Eth comes with a hook for that, which is called useScaffoldContractWrite from hooks.scaffold-eth. So let's import that. And the basic structure of this is we're going to have some parentheses and brackets. And the first thing that we need to specify is the contract name, which is your contract, and the function name, which is going to be input. And input does take an argument. So if you're using these hooks, the way you give the arguments is with args, colon, brackets, and we're going to set this equal to player choice. So when we call this function, which we need to give a name, let's put in write async up here. I'm not really sure what that does, but we can rename it to whatever we want after we write async. And we're going to call this input, because that's what it is. So we'll just keep all the names pretty consistent. Here we have a type error because when you send numbers over to Solidity, it's actually all big ints. And in Java, in TypeScript, it's normal numbers. So wait, not big number, big int. So we need to typecast player choice, which is a normal number to a big int. And that should solve our little error there. Looks good. Okay, so we have our input and we have our set player choice. So when we click any of the buttons, it's going to do two things. It's going to call, or it's going to set the player choice, and then it's going to call the input function that we just made. So let's make a little anonymous function, and we'll just say, we'll set player choice. If it's rock, that's 1. So we'll set it to 1, and then we'll call the input function. And so we don't need to pass any arguments into here because we already specified the arguments we're passing in here. So we can just leave that input function blank. And that looks good. So let's save this, and then we will just copy and paste this a few times. Starting from the button, yank that, paste, and paste. Cool. So our first one's rock. Second one is going to be scissors or paper. Rock, paper, scissors. Make that a 3, and we will change this to scissors. All right, let's make sure that looks good up here. Oh, I choose their weapon. No, you are choosing your own weapon. Okay. So now when we click these buttons, we can check our debug contracts tab and make sure everything's working in order. So we'll do rock. Don't forget to grab funds if you restarted this project for some reason. Okay, we have funds now, so we'll go rock, and this shouldn't, oh, that did work. Okay, let's see, paper. Okay, so you have to double click these buttons. And the reason is there's something about memoization. It's some React front end stuff. I don't want to get into it because this is a kind of a Scaffold-Eth demo, not a React workshop. So we'll just deal with that. Double clicking is not the end of the world. Cool. So we have our first thing set up. Now we want to set up another card for displaying the winner and also having like an execute function or execute button. So we'll call this play/reset. And we need some buttons. So we'll have a play button and a reset button. Cool. So let's wire those up now. So when you click the play button, it'll be another on click. And we need to make an anonymous function call to a play function. So let's make another sort of function using the useScaffoldContractWrite, since we're going to tell the contract to do something. And we have our contract name, your contract, and a function name, which for the play function, we're going to be just calling the play game, because determine winner is going to be called into here. So we don't need to mess with determine winner. The play game is going to just set the global winner here. So we just need it to play the game. Why is that not? Is it not called play game? It should be called play game. Play game. Okay. So we'll have write async, and we'll call this play game. Okay. So when we click this button, we are just going to call the play game function. Now, below, we'll want to have a winner displayed. So we'll be like, and the winner is ... And then we'll just display the winner here. So we do need to set the winner and to make a winner. So let's make another use state thing. We'll say the winner and set the winner equal to use state. And the winner by default is 0. So we need to set the winner equal to something. So we want to get instead of using useScaffoldContractWrite, we'll want to use ScaffoldContractRead to actually get who the winner is. So let's make another hook called useScaffoldContractRead. And we give it basically the same things, the contract name, which is your contract, and a function name. Now, this is a little confusing because winner is not actually a function, but I think under the hood, everything in Solidity is a function. So that's why that works out like that. And we want to make a JavaScript function here, or a TypeScript function rather, that is just referring to my notes here. We want to make a TypeScript function that returns the current winner. So we want it to play. We'll have a play function, and then we'll have that do the game logic and then return the winner. So for useScaffoldContractWrite, there's a thing called write async, and then you can rename the function. For useScaffoldContractRead, instead of write async, there's data, and then we can rename that to whatever we want. We'll just call this the result. And let's make a normal TypeScript function called play. And what this is going to do is it's going to run the game logic. So we're going to call the play game function we just made up here. We're going to call this. And by the time this is called, the two inputs are already going to have their numbers. So this is just going to compute who the winner is. So we'll call play game, and this will set the winner in the contract. And then we want to retrieve the winner from the contract and put it into our front end. So we want to set the winner here. Set winner. And then remember, whenever we're sending things to the contract, we want to typecast that number from our TypeScript, from our front end as a big int. And then when we're getting things from our contract, or getting a number from our contract specifically, we want to typecast that back into a number. So we will have the result become a number. Cool. So now our winner is all set up, and our winner down here has no more red underline. So everything looks good. Let's just consult the front end real quick. Okay, so we have our input here, play reset, and the winner is... I really don't want to spend too much time on the way everything looks, but bare minimum in addition to cards. Let's just put a little margin here on our card so it's spaced out. Cool. I keep on writing what I'm saying. This is not a play button, it's just play. It's a play button that just says play. Okay, now for the reset, this one should be fairly simple. We're just going to have on click. And on click, we're going to call an anonymous function that calls the reset function. And so this is another use scaffold contract write scenario. I like to separate my scaffold contract writes and my reads. So we'll separate that. And let's just copy paste this because this is fairly straightforward. This is going to be reset. And we're going to call the reset function in here. Oh, this is yeah, that's a write function. Okay. There we go. No more red underline. Looks good. So I might have missed a few things, but we'll see if it works. Okay, well, first of all, this play here isn't being called anywhere. And that's going to be the play game function. Yeah, right here. So this is calling play game, but I think what we want it to call is actually play. Sometimes I get confused with these names. Okay, so that calls play, and play over here calls play game. Okay, that looks correct. All right, let's test it out. If anything goes wrong, we always have the debug contracts tab. All right, well, let's start by resetting it. Okay, front end. Player one chooses rock. Double click rock. Let's see if that loaded in. Okay. Player two chooses paper. So that should beat rock. So here we're expecting a 1. All right, that loaded in correctly. And we'll click play. We'll click play again. We'll double click it. And the winner is, come on. All right, let's double click it really fast. All right, and the winner is 2. So that's good. Looks like it works. We'll reset. I think we have to click this twice as well. Okay, looks like things are reset in here, but they're not reset in the front end. And the reason is that the reset, this winner here needs to change when the reset function is called. So we probably need to do one more thing, which is in the reset, it's going to call the reset button, but it's also going to do another thing. It's going to reset the state. So let's delete that and we'll have it call the reset function. And we're also going to have the set winner. We're going to set winner equal to 0 whenever we click that. All right. We're getting some red stuff. I don't know if it's just, okay, I cleaned it up. All right, let's reset. Everything's at 0. All right, this time, player 1 is going to choose scissors, and player 2 is going to choose paper. So in this case, player 1 should win. So we're expecting a 1 down here. Double click play, and the winner is, just click it one more time, 1. Good. Hit the reset. That works. Let's just do another test here for sanity's sake. Player 1 is going to choose rock. Player 2 is going to choose paper. And so we're expecting a 2 down here. Double click play. Triple click play. Click it one more time. All right, looks like those things got muddled up. So in our more advanced version of rock, paper, scissors, obviously we're going to have a lot more checks. It's going to be a lot less janky. This is like, this is just a bare minimum example on, okay, there we go. On showing you scaffold contract write and read and kind of showing off some caveats. Another caveat is if you don't have use client up here for some reason, make sure you add that or else you're going to get an error that is not helpful at all. All right, so our game works, and that is our whole front end. Thank you, everyone.